Howdy, hello everybody. So in this video, I'm going to kind of give you the rundown of how to end up creating this Google Sheet of our launch data. So basically, what we ended up doing for this activity, 114, is we ended up basically making some changes to our device the first 15 minutes of class. And basically what we're wanting to do is we're wanting to end up creating or make some changes to our launcher so that whenever we launch it onto this grid paper, basically it can land the closest to our target, which is 0, 0. We want to get as close to that as possible. And so basically what we want to be doing is we want to minimize the distance between where each rice packet lands, that being the distance from where the rice packet lands to the origin 0, 0, because that's our target. And so what we're going to do here is we're going to make marks where our rice packet ends up landing. And then what we're going to end up doing is we're going to create we're going to find out what coordinate that is. So if you go over 1, 2, 3, 4, 5, 10, 15, 16, 17, 18, 19. So as you can see, it's -19 for our x coordinate. And then in terms of our y coordinate, which remember y is vertical, we got -5, -6, -7. So that's the coordinates of these. So what we're going to end up doing is you're going to write that in your Google Sheet that you'll end up creating. And so if we continue, they also find out the actual distance by measuring it out. And so you'd get the measured distance in there as well. But then also what we're going to end up doing is we're going to actually mathematically determine the distance as well. And what you're going to find, hopefully, if you did everything right, you're going to find that those values are pretty close. All right. So for each team, there's different launch data. Now I'm just using this data because it's exemplary data, it's example data. The data that you're going to use is going to be your actual team's data. But what I'm going to do for this is I'm going to actually just use this data as an example and show you what we'd end up doing. And so what we want to do is we want to end up writing down all these points. I'm just going to do the first 5 points from here, and that's what I'm going to end up putting into my sheet. So starting off, what you're going to want to do is you're going to want to create a new Google Sheet. Now, how could you do that? Let me just go ahead and show you. You can type in sheets.new. You type in sheets.new, guess what? That's going to create a whole new spreadsheet for you. Then what I'm going to go ahead and do is I'm going to put in 1.1.4 launch data. That's what I'm going to put down. Now, what we want to end up doing is we want to end up having each row consist of each point's coordinates. So what we're going to do is we're going to start up here. We're going to type x coordinate. Now, this is going in cell A1, as you can see. If I press tab, I'll go into this next cell. In the next column, I'm going to create this column header here. This is called B1. And what we're going to put there is the y coordinate. Okay? So now, what you can also put over here is the measured distance. And so this measured distance should be in inches for us. For them, it's actually in centimeters. So I'm going to put down centimeters, but I want you all to have inches in there. What we can also do is you can see this is overflowing into that next cell. I always like to end up going over here, just dragging that out. What you can also do is if you right-click this, you can resize the column, then you can click Fit to Data. That will automatically adjust it for you to the width that it needs to be. But so now what we're going to do is we're going to go ahead and we're going to write down these points. So I'm going to find the x and y coordinates for 5 of these points here. All right, so this first point right here, I see that my x is going to -25, so I'm going to go backwards, -24, -23 is the x coordinate, -23x, the y is a +20, so -23, and then we got 20. Now, if I'm going through here, punching in the number, and then so after I hit -23, if I press tab, I can put in the next y value, 20. If you press enter after doing that, it's going to automatically go down to the next row for you. So now we can go to this next point. So now we're going to go here. We need to find the x coordinate of this first. So it's -19. And then we're going downwards to a -7 because this is in quadrant 3. Both of the values should be negative. So we got -19, -7. So we're going to go ahead and write that down. -19. I'm going to press tab on the keyboard. I'm going to type in -7. And if I press enter, it's going to go back to right here. So now let's get our next point. I'm just going to start on the left here and then keep working my way. So let's go to this guy. So I got -16 for x. And then I've got 8 for y. So -16 for x. And 8 for y. -16, 8 for y. Next one, We're going to go down here to this guy. We've got for the x negative 16, for y negative 21, which is making sense, right? Because it's in quadrant 3 there. Then we're going to go down to this next point. I'm going to choose this point right here. We're going to go to negative 12, and then we're going to go 10 for y is what that is. So negative 12 and 10. Now for you, what you should end up finding here is that you have 10 of these points, right? I'm just doing 5 just for an example here. And so now what we want to end up doing is we should measure out the distance. So this is the point where you would end up going in here, and just like they have up here, you're going to use a ruler to actually measure out the distance from 0, 0 to that point. Now remember, you should be using inches for us. In this example, they have centimeters here, but I want you all to use inches. But we find that out. And so, if I go to this data right here, they actually measured those distances out for me, and so I could end up using that. But what I'm going to do is I'm going to go ahead and skip that part, and I'm going to do mathematical distance. This is going to be in centimeters. For you all, it should be inches. We're going to right-click this. We're going to resize column. We're going to fit that to the data just so that it works like that. And so now what we want to end up doing is basically we want to find out, well, what's the distance of this point to our origin, which was our target. And so we're basically mathematically determining, okay, for this point right here, what's the distance from here all the way to this point 0, 0. And so as you'll remember, we have the distance formula that we can use. Now the distance formula is this right here. D is equal to x2 minus x1 quantity squared plus the quantity y2 minus y1 quantity squared is the square root of all of that. And so now if we've got it where x1 and y1 are the target center, well guys, isn't it the case where the target center is 0, 0, or 0, 0, where x1 is 0 and y1 0? Well, if I have a number x2, let's say that is 3. If I have 3 minus 0, what does that equal to? Exactly, it's equal to 3. And so do we really need to include x1 and y1 in here if it's 0? No, we don't. And so what we can end up doing is we can just take x2 squared plus y2 squared and then take the square root of the sum. Then we can find the distance, how far that is. And so what I'm going to end up doing here is I'm going to type this up here in the fx. Basically what that means is we can use a function for this. I'm going to press equals. And basically we're going to be using Google Sheets so that we can automate or streamline this process of being able to calculate out the distance of these coordinates, or this point, from the target. So what we are going to do is we're going to put square root. And so basically what I'm doing is I'm creating the distance formula. I'm creating this function. So we're going to take the square root, and remember it's x2, which x2 is the x coordinate of the beanbag landing location. Well, what we can end up doing in Google Sheets is we can actually click on cells while we're typing in this function. So you can also just type in literally A2. And what I want to do is I want to square that. Now, why do I want to square that? That's because this is x2. So we need to take x2 squared plus, if we look back at our equation, it's y2 squared, right? y2 squared. So now y2 is actually the cell B2. I'm going to square that. And then what I can do is I can press enter after this. Now, once again, why are we not including minus 0 and minus 0 here? Because simply any number minus 0 is just that number you're subtracting 0 from. So now I can press enter. And then what we're going to see is that there's a suggested autofill. So if you actually press enter or press control plus enter or this green check mark, then it's going to automatically fill that out. And so as you'll see here, it ends up referencing the x coordinate squared plus the y coordinate squared. Okay, if we go here, same thing. For this row, it's that x coordinate and y coordinate. Same here, and then same thing here. It should be for all 10 of your functions. You can go through and you can check that to make sure, but it should be the x coordinate value in this row squared plus the y coordinate value in that row squared. And so what we basically did here is we mathematically determined using our distance formula what that distance is of our beanbag from our target. And so now, as you can see, I've got quite a bit of high numbers here. I got some big numbers. Well, the reason for that is because my values are in centimeters. Taking into consideration my values are in centimeters, they actually should be larger than your values that you end up finding. And so what we can end up doing here is you should have 10 different values. You should go all the way to 11. But what we can do is we can also perform some summary statistics on this data. Now, what I could end up doing is I could calculate out the average here of our data. Now, what this is going to tell us, if we take the average of this, it's going to tell us on average what our accuracy is, right? Because this distance that our beanbag lands from the target is actually telling us the error. And so error is how we quantify accuracy. If you look at the e-text, they're going to end up mentioning that in here. So how we quantify accuracy is we find the error. So it's the mean of the measured values minus the target or accepted value. And so basically the closer our distances to 0, that means the more accurate our launcher is. So what I'm going to do here is I'm just going to find the average of our distances for this. And so what I'm going to do is I'm going to put equals, and I'm going to type in average. Now what this allows us to do is take the average of data set. So what I can do is I can click on D2, then I can hold down Shift, and then click on D6. Now what that's going to do is it's basically going to take all the data from D2 to D6 that we have in this orange little rectangle here, and then it's going to find the average of that data. And so now on average, basically what I end up finding is that on average, my launcher was 22.13 centimeters away from the target about whenever the beanbag landed. So that gives us some information on the accuracy of this. What we can also end up doing is we can also find the range. And so whenever they go down here, they talk about quantifying precision. And so what you can end up doing is you can end up creating a circle around all your launch data points. That's going to be in your actual data here. And so if you end up scrolling down, let's see here, do they have it? Maybe they have it down here. They had it in here at one point. I don't know if they actually still do have it. They might not. Yeah, they do not. But what we can also do to quantify precision is we can also calculate out the range. So the range is just the max minus min, right? So we could find the range of that data. And basically a quick estimate of the range for our data could be just by us measuring the diameter of the circle that we form that basically fits all of the launch location data points. And basically it's the smallest diameter that fits that. And so in here with our data, we can end up creating a circle, right? And then that smallest circle that we can create, if we find the diameter, that will actually tell us our range. What we can also do though in here is we can mathematically determine our range as well. So we could do this. We could actually do range of x values. And then we could also find the range of y values. And this could also end up telling us the range. So I'm going to draw this out a little bit. But the range of x values, all we got to do to calculate that out is we just type in range. Sorry, let me put that all in caps. Range, and then we can type these guys in. Then we can press enter. Ooh, that was giving me a little bit of an error. Let's hear. So we need to find, okay, so basically they don't have a function called range. What we can do is instead we can take the max of this data right here, A2 to A6, and then we can subtract the minimum of that data, A2 to A6. So that's going to end up giving us the range of values for the X. And then if I look at the suggested autofill, we can press the green check mark and let's see what they've got there. So they have A3 to A7. That is incorrect. What we want to do is we want to find the range for the Y values. So we could put in B2 to B6 here. That's what it is for me. Now, obviously, it's going to be different for you because you have 10 values. And then the minimum, I can erase this and I can just click right here too, hold down Shift, click there again. And then that's going to end up giving us the range of the Y values. And so as you can see, in terms of our data, we're pretty precise in terms of the x-axis. We haven't moved that much, but in terms of our y values, you can see that there's a whole lot bigger range. So in terms of the y-axis, we're not all that precise. Okay. So that can end up giving us some information on how precise our data is for the x and y values. But anyways, this is the basic calculations that we're going to want to perform. What we might want to end up putting in here is average distance. I'm going to put it in centimeters once again, but for you it's going to be inches. But that is basically what we're dealing with here, and these are the type of calculations we want to perform in our Google Sheet. All right, hope that was helpful. Thank you all so much. Bye-bye.